Hello. Can you hear me?
Yes, I can hear you. Are you able to hear me?
Yes, I can hear you. I'm going to make you the co-host so you can share your screen. Is there anything else you'll need?
Um, if you could please, are you going to be recording this session?
Yes.
And would you be sharing it with me afterwards?
It's recorded to the cloud. I can send an email to MLH to have them send over the recording if you'd like that.
Yes, please. Yeah, because I needed some snaps from the event, so I thought maybe if I have the access to the video, or if you could take a few snaps and share it with me, anything would work for me.
Yes, awesome. I can do that.
Thank you.
Perfect. Okay, you should be able to share your screen now. Your co-host, and I'll make the announcement, but let me know if there's anything else you need.
Okay. All right. Thank you so much.
No problem.
Should we get started?
Yes, you can get started whenever you're ready. Are you able to share your screen?
Yep, let me go ahead and share my screen. Are you able to see my screen?
Yes, everything seems to be working.
All right. In that case, let me get started. Hello, everyone. Today we are diving into the world of data science, where insights meet decisions. Join me as we explore its significance and diverse techniques shaping various industries. Let's begin by discussing about data science and its related fields. Data science is more than just a buzzword. It is an interdisciplinary field that brings together various domains to extract meaningful insights from data. At its core, data science is the field that employs scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data used to take specific action to drive business. What makes data science truly powerful is its interdisciplinary nature. It's not confined to one specific discipline, but draws from a diverse set of fields. Data science brings together the strengths of disciplines like computer science, statistics, mathematics, and domain expertise that allow the allow the data scientists to make the sense of vast amounts of data. This interdisciplinary approach enables data science to be applied across various industries from finance to healthcare, from marketing to environmental science, etc. So, the true data science initiatives involve collaboration among these different areas to drive innovation and decision making within a business or an organization. Data science plays a crucial role in driving decision making processes in various industries. It's the driving force that empowers organizations to navigate through complexities and make informed choices that align with strategic objectives. Now, depending on the business questions we need to answer, data science offers a spectrum of techniques with varying complexity and value. Let's explore these techniques in the context of analytics types. Firstly, we have the descriptive analytics. This is about understanding what is happening in our business. It provides a snapshot of past events, answering questions like, did the sales go up or down? Moving to diagnostic analytics, this technique helps to uncover factors to drill down to the root cause of a problem. It answers crucial questions such as why did the sales go down? Next, we have the predictive analytics. This is like the crystal ball of data science, and it helps in answering questions such as what will happen next. Therefore, we can say that it involves forecasting future trends, enabling proactive decision making. Lastly, we explore the prescriptive analytics. Here, data science guides us on the recommended actions for the desired outcomes. It answers questions such as, what do we need to do next? This is about prescribing the optimal strategies for success. In conclusion, data science stands as the cornerstone of informed decision making across diverse industries. Now, let's dive into understanding the data science life cycle. With it's like a structural approach that guides us through the journey of extracting insights from data. This life cycle is a series of steps, each playing a crucial role in turning raw data into actionable knowledge. The life cycle begins with business understanding. In this phase, we collaborate closely with stakeholders to define the problem, establish objectives, and formulate questions that can be answered with the help of data. This phase is all about aligning data science goal with the business goals, and it sets the foundation for the entire data science process, ensuring that our efforts are aligned with the overarching business objectives. Next up is data mining. In this phase, we gather relevant data from various sources, ensuring it covers the breadth and the depth necessary for our analysis. This phase involves understanding data formats, storage, accessibility, etc. Effective data collection is crucial since the quality and the comprehensiveness of our dataset can significantly be impacted by the type of dataset that we choose. Once we have our data, we move on to data preparation and cleaning. This involves cleaning, transforming, and organizing data to make it suitable for our analysis. Dealing with missing values and handling outliers are the key tasks in this phase. Even though the data preparation is not the most glamorous step, but it's where we lay the groundwork for meaningful insights. With our data in hand, we move to the data exploration. Here, we analyze and visualize the data to gain a deeper understanding. Exploring the data helps us identify patterns, trends, and potential insights, which will help in paving the way for informed decisions in subsequent stages. As we prepare and explore our data, we engage in feature engineering. This step involves creating new features or modifying existing ones to enhance the predictive power of our models. It's a creative process that amplifies the signals in the data. Therefore, feature engineering is like transforming raw data into a more refined form, extracting the essence that is most relevant to our objectives. Finally, we step into the modeling phase. Here, we apply various machine learning algorithms to build models that help us answer the questions posed in the business understanding phase. It's about finding patterns, making predictions, or uncovering hidden insights. But our journey doesn't end with modeling. We move on to evaluation. Here, we assess the performance of the models, ensuring they meet the predefined objectives. It's critical to validate the effectiveness of our approach. We don't just build models for the sake of building them. Evaluation ensures that our models are robust, accurate, and aligned with the goals we set at the beginning. With insights and analysis, we enter the data visualization phase. Here, we present our analysis and results through visualization that make complex information easy to understand with narratives that resonate with diverse set of audiences. After implementing all these steps, our journey completes with feedback and iteration. We gather feedback from stakeholders, assess the model's performance in the real world, and iterate on the entire process. This continuous feedback loop ensures our models stay relevant and effective over time. Therefore, the data science lifecycle isn't a linear path. It's dynamic and iterative process. Each iteration refines our models, enhances our understanding, and ultimately improves our ability to derive value from data. By navigating through these components, data scientists transform data into knowledge, unlocking insights that drive innovation and informed decision making. Now, let's quickly touch on which roles are involved in this life cycle. In an organization, we have roles like business analyst, data engineers, and data scientists. Business analysts are involved in the business understanding phase and the visualization phase, where they have to communicate with the stakeholders. Data engineers are involved in the data mining, data cleaning, and data exploration phases. And the data scientists are involved in the data exploration, modeling, and the visualization phases. As we can see, there is some overlap between the roles, and that is why collaboration is crucial across these different roles. And based on the individual organization, these roles may have different set of responsibilities. Now we'll be moving on to different types of case studies where data science has proven to be useful. Let's dive into the fascinating world of Netflix and uncover how their innovative use of data science has transformed the way we experience entertainment. Imagine a streaming platform that not only offers a vast library of content but also knows exactly what you want to watch. This is the magic of Netflix's recommender systems, a prime example of how data science elevates user satisfaction and engagement. Netflix wanted to enhance user experience and engagement by helping the users get the right recommendations among the various options available on the streaming platform. And to achieve this objective, collaborative filtering algorithms and machine learning models can be used in the context of the recommender systems. These algorithms delved into the depths of user data, analyzing preferences and behaviors to understand the unique taste of each viewer. Now, let us look into the details of the recommender system. The recommender system filters over 3,000 titles simultaneously using about 1,300 recommendation clusters. It employs item to item similarity measures to identify content similar to what a member has seen. And finally, recommendations are made based on a user's preferences. Some of the factors considered for recommendations are: the system takes into account various factors when it's estimating the likelihood that a user will watch a particular title. Factors include the user's viewer history, ratings given to other titles, preferences of members with similar tastes, and the device used for content consumptions. Technological components used to build the recommender system are: Netflix's recommender system integrates AI, data science, and machine learning. The system stores data on user hobbies and watching habits to enhance the personalization of recommendations. The impact of the recommendation system is that it has become a crucial component of Netflix's revenue model. Approximately 80% of Netflix's viewer activity is attributed to the personalized recommendations. Let's explore how Uber, through the strategic use of data science, revolutionized the transportation industry with its dynamic pricing model. This innovation not only transformed how we move, but also demonstrated the power of machine learning in optimizing real time decision making. Picture this: you are you need a ride and you open the Uber app. What determines the fare you see? That's the magic of Uber's dynamic pricing, a game changer in the way we experience transportation. The objective of this was clear. Uber aimed to optimize pricing in real time, not just for the benefit of riders, but also to maximize revenue and enhance overall rider engagement. This marked a significant shift from traditional fixed pricing models. So, how did Uber achieve this? By analyzing vast amounts of ride data and external factors such as demand, traffic patterns, and events, Uber's algorithm dynamically adjusts pricing to reflect the current market conditions. And what was the impact of this dynamic pricing strategy? It wasn't just about adjusting fares, it was about unlocking a new level of efficiency. Uber not only maximized revenue by charging more during peak demand hours, but also ensured rider engagement by offering competitive prices during the off peak times. Let's visualize this in action. Imagine a busy night in the city where demand for rides surges. Thanks to the dynamic pricing, Uber seamlessly adjusts fares, making more drivers available and ensuring you can get a ride when you need it the most. As we conclude our exploration of Uber's dynamic pricing, remember that this case study exemplifies how real time data analysis and machine learning can transform traditional business models. Uber not only changed how we move around, but also showcased the power of dynamic decision making in the modern era. Now, let's dive into the realm of public health surveillance and explore how Google, through innovative use of online data, reshaped our approach to monitoring and predicting the spread of influenza with Google flu trends. In the quest for real time insights into the spread of influenza, Google took a bold step by harnessing the power of data. The result was Google Flu Trends, a groundbreaking application of online data analysis for public health. The objective was clear and crucial: monitor and predict the spread of influenza in real time. By analyzing search query data, Google Flu Trends aim to provide insights faster than traditional surveillance methods, offering a proactive approach to public health. How did Google achieve this? The approach was ingenious. By analyzing the search query data, Google Flu Trends identified patterns and trends that correlated with the prevalence of flu like symptoms. This real time analysis allowed for quicker response and intervention. And what was the impact of this innovative approach? Google Flu Trends provided real time insights into the spread of influenza, demonstrating the potential of online data for public health surveillance. It offered a faster, more agile response and more agile response to the emerging health threats. Let's visualize this in action. During flu seasons, people often turn to Google for information about symptoms and treatments. Google Flu Trends detected these patterns in search queries, allowing public health officials to identify potential hotspots and allocate resources accordingly. As we conclude our exploration of Google Flu Trends, remember that this case study exemplifies the transformative power of online data in the public health domain. Google's innovative use of search query data paved the way for more proactive and efficient monitoring of influenza outbreaks. Now, let's explore how Facebook, a pioneer in social networking, utilized the power of data science to deepen our understanding of social connections. Through the application of graph theory and network analysis, Facebook not only enhanced user engagement but also redefined how we connect with others. As we navigate the vast landscape of social media, Facebook stands out as a leader in fostering connections. But how does Facebook truly understand and optimize our social interactions? The answer lies in the social network analysis. The objective was clear: understand social connections and interactions to enhance user engagement. Facebook aimed to go beyond a simple platform for sharing. It aspired to create an ecosystem where connections were not just facilitated but optimized for a richer user experience. How did Facebook achieve this? This approach was rooted in data science, specifically graph theory and network analysis. By treating social connections as nodes and the relationships as edges, Facebook could map and analyze the intricate web of interactions within its platform. This approach allowed for targeted content delivery and improved friend suggestions. And what was the impact of this data driven approach to social connections? Facebook's social network analysis significantly enhanced user engagement. By understanding the dynamics of friendships, group affiliations, and content preferences, Facebook could deliver personalized content and suggest connections that resonated with users. Let's take a closer look into this. When you log into Facebook, the content you see isn't random. It's a result of intricate algorithms analyzing your connections and interactions. From personalized news feeds to friend suggestions, Facebook's data driven approach ensures that your social experience is tailored to your preferences. As we conclude our exploration of Facebook's social network analysis, remember that this case study underscores the transformative power of understanding social dynamics. Facebook's use of data science not only connects us with others, but ensures that these connections are meaningful and enriching. Now, let's explore how Zillow, a game changer in the real estate industry, transformed the way we assess property values with the innovative Zestimate. By applying advanced statistical models to vast amount of housing market data, Zillow empowered users to make informed decisions about one of the most significant aspects of their life, which is the real estate. As we navigate the complex world of real estate, Zillow emerges as a key player, not just a property listing platform, but as a pioneer in property valuation. The Zestimate is more than just a number. It's a testament to the power of data driven decision making. The objective was clear: revolutionize the real estate market by providing users with accurate estimates of property values. Zillow sought out to empower individuals in their real estate journey, offering a tool that goes beyond a simple listing to provide valuable insights into property values. How did Zillow achieve this? The approach was grounded in data science and advanced statistical models. Zillow's team analyzed extensive housing market data, considered factors such as location, property features, and market trends, and by leveraging this wealth of information, the Zestimate model could generate accurate property value estimates. And what was the impact of this innovative approach? Zillow revolutionized how users approached the real estate decisions. The Zestimate empowered individuals with a tool that offered transparency and accuracy in the property valuation. Users could now make informed decisions, whether buying, selling, or refinancing, with confidence. Let's visualize this in action. Imagine you're considering selling your home. With this estimate, you can get a real time estimate of your property's value based on the latest market data. This not only aids in setting a competitive asking price, but also provides transparency in the valuation process. As we conclude our exploration of the Zillow's estimate, remember that this case study showcases the transformative potential of data in the real estate market. Zillow didn't just provide a platform for property listings, it offered a tool that democratized property valuation, putting the power of informed decision making in the hands of its users. Next, let's embark on a journey beyond our planet and delve into how NASA, at the forefront of space exploration, utilized the power of data science for in depth analysis of the Martian landscapes. Through computer vision and image analysis, NASA's Mars rover missions provided us with unprecedented insights into the geological features of the red planet. As we gaze at the night sky, NASA's exploration of Mars stands out as a testament to the human curiosity. But how does NASA make sure of the vast amount of data collected by the Mars rovers? The answer lies in the application of data science to image analysis. The objective was profound: contribute to our understanding of the Martian landscape by analyzing images captured by the Mars rovers. NASA aimed to unlock the mysteries of Mars, identifying geological features that hold clues to the planet's history and its potential for life. How did NASA achieve this extraordinary feat? The approach involved using technology and science. NASA's Mars rover missions employed computer vision and image analysis techniques. These technologies allowed the rovers to see and interpret the Martian terrain, identifying rocks, soil patterns, and other geological features. And what was the impact of this data driven exploration? NASA's Mars rover image analysis significantly contributed to our understanding of Mars. By understanding geological features, scientists gained insight into the planet's history, potential habitability, and the conditions that shaped its landscape over time. Let's take a glimpse into this process. The Mars rovers, armed with sophisticated cameras and analytical tools, captured images of the Martian surface. These images, when subjected to computer vision and image analysis, reveal details that are crucial for unraveling the mysteries of Mars. As we conclude our exploration of NASA's Mars rover image analysis, remember that this case study goes beyond the space exploration. It demonstrates how data science can bridge to other worlds, unraveling the mysteries of the cosmos and expanding our understanding about the universe. Finally, let's explore a groundbreaking case study that reveals that transcends the boundaries of healthcare and artificial intelligence. The IBM Watson for oncology. This remarkable system is revolutionizing cancer care, empowering oncologists with unprecedented insights for more informed and personalized treatment decisions. As we confront the complexities of cancer, IBM Watson for oncology emerges as a beacon of innovation. It's not just a tool, it's a cognitive computing system designed to assist oncologists in navigating the vast landscape of medical literature, clinical trials, and patient records. The objective here is profound: enhance cancer care by providing oncologists with an intelligent assistant. IBM Watson for Oncology aims to bridge the gap between the exponential growth of medical knowledge and the need for personalized treatment decisions in oncology. Let's dissect the key components of this transformative system. Watson for Oncology processes extensive datasets, assimilating information from medical literature, textbooks, and patient records. The system harnesses power of cognitive computing to understand unstructured data, ensuring it stays abreast of the latest research and clinical insights. By analyzing a patient's medical history and genetic information, Watson for Oncology provides personalized treatment recommendations based on the most relevant and evidence backed insights. Oncologists leverage the system as a decision support tool, gaining access to insights on treatment options, relevant clinical trials, and the latest research findings. The impact of IBM Watson for oncology is profound. Oncologists equipped with Watson for oncology make more informed and personalized treatment decisions. The system accelerates the review of extensive medical literature, saving valuable time for the oncologists. Watson for Oncology ensures a consistent application of latest medical knowledge, reducing variability in treatment recommendations. As we applaud this innovation, it's essential to recognize the challenges that come with it. Seamless integration with existing clinical workflows is crucial for effective implementation. The system needs to continually learn and adapt to evolving medical knowledge for up to date and accurate recommendations. In conclusion, IBM Watson for Oncology stands at the intersection of technology and healthcare, reshaping how we approach cancer care. It exemplifies the potential for artificial intelligence to augment human capabilities, offering a glimpse into future where personalized data-driven insights redefined the landscape of medicine. Next, let's dive into some of the major areas of concern for data science: AI bias and data security. In our exploration of case studies and applications, it is crucial to shed light on these aspects that not only influence the accuracy of the models, but also carry significant ethical and practical implications. Firstly, let's address the AI bias. As we entrust algorithms to make decisions in various domains, the question of fairness arises. AI systems, like any other creations, can inadvertently inherit biases present in the data that they are trained on. This can lead to unequal outcomes and perpetuate societal disparities. It's imperative that we acknowledge, identify, and rectify these biases to ensure that our models are fair and just. Now, shifting our focus to data security. In the age of information, protecting sensitive data is important. Data breaches can have severe consequences, compromising individual privacy and organizational integrity. Ensuring robust data security measures, including encryption, access controls, and regular audits, is not just a necessity but a responsibility. As stewards of data, we must prioritize security to maintain trust and uphold ethical standards. Mitigating AI bias and ensuring data security require proactive measures. For AI bias, implementing diverse and representative datasets, regular audits, and transparent model development are crucial. When it comes to data security, adopting encryption standards, monitoring access points, and fostering the culture of cybersecurity awareness are vital steps. By integrating these strategies, we can build more robust and ethical data science practices. In conclusion, as we immerse ourselves in the fascinating world of data science, case studies, and applications, let's not forget the responsibility that comes with wielding this transformative power. Addressing AI bias and ensuring data security are not just checkboxes, they are ethical imperatives. By navigating these challenges with diligence and commitment, we can harness the true potential of data science for the betterment of individuals and society at large. In this presentation about data science and its applications, we started with an overview recognizing data science as the driving force behind informed decision making in various industries, navigating complexities, and aligning choices with strategic objectives. Exploring the spectrum of analytics types, from descriptive to prescriptive, we showcased how data science offers a diverse toolkit to answer crucial business questions, making it not just a field, but a strategic ally in shaping the future. As we delved into the case studies and real world applications, we navigated through the collaborative roles of business analysts, data engineers, and data scientists. The dynamic interaction between these roles highlighted the importance of collaboration, acknowledging that responsibilities may vary based on organizational needs. However, our journey didn't stop there. We recognized the ethical considerations embedded in the data science lifecycle, touching upon the critical aspects of AI bias and data security. These are not just challenges, but our responsibility to uphold fairness, transparency, and trust in our data driven endeavors. In the ever evolving landscape of data science, let's carry these insights forward. Embrace collaboration, foster ethical practices, and remain vigilant to the responsibilities that come with wielding the power of data. As we step into a future shaped by insights, decisions, and transformative technologies, let's continue exploring, learning, and leveraging data science for positive change. Thank you all for joining me for this talk. With that, I open the floor for questions.
Hi, it's Gabriella from MLH. I had a quick question. I was curious, I guess like what trends you foresee kind of popping up in the horizon in data science for like the next year or so.
Well, the current latest trends is all about the advancements in the natural language processing domain. With the like every day we see new innovations and new foundational models being developed, and these models can be used to develop like a diverse set of applications. So I feel we will be seeing a lot of development in that area, specifically in data science, in the upcoming year.
For sure. It's definitely been really interesting to look at kind of like all the applications of I guess like GPT technology in particular has been really, I guess, like fun for me to play around lately.
Yep, definitely.
Looks like we have a question in the chat. Um, I wanted to ask that if I wanted to write my code according to industry standards while developing some projects in data science, what are some ways or methods I can use to kind of follow industry standards?
Um, it largely depends on what type of application that you're trying to develop. The first and foremost suggestion would be like just to follow the standard provided by that particular programming language itself. Like Python has its own standards, and like every language in data science they end up using R and all that. So first thing is to follow the standards, and the second thing would be to focus on efficiency, since data science comes with like we use a lot of, basically we do a lot of data processing, so efficiency of code also matters. So I would just say like just follow the standards, and it also depends on the type of applications. And definitely like unit testing and all that things are always helpful to test your code against various test cases.
Awesome.
Okay, I see Ralph's question. So
Yes.
data science and machine learning are interconnected with a large aspect, right? Yes, definitely. Machine learning is like a core component which helps us do data science. Machine learning algorithms are the ones that help us like get some insights into the data, or help us predict an outcome and all such sort of things. So they are definitely interconnected. The data cleaning part. So Rohan is asking, can you elaborate a little on data cleaning part? So the thing is, when we do like projects, like an academic projects or a personal project, we usually get data sets from repositories like the UCI machine learning repository or something like that. The data available there is like very very standardized, and it's clean, and it has all the values. But when we deal with the real world data, it's messy. It has a lot of missing values. It has a lot of unwanted values, and we usually need to conduct like an exploration and understand like the impact of these missing values and how we can better like fill in for those missing values. And then like we there also tend to be outliers in the data set. So if we end up training a machine learning model based on a biased data, the model responses will always like end up being, not always, but in most cases it might end up being biased. We also need to look into the distribution of the data. Like we cannot have imbalance in the class, specifically in the classification problems. So all these steps need to be taken before we use the data in the modeling phase. I hope that answers your question. What are the Rohan is asking, what are the factors that make data more suitable for machine learning? Again, it depends on the type of problem that you're trying to solve. For example, in a classification problem, you need to make sure that the classes are not highly imbalanced. There has to be some sort of a balance in the classes that are present. And for example, if you're doing natural language processing, you cannot like directly use the text data into the machine learning models. You will have to perform text data cleaning and then transform it to extract features that are suitable for machine learning. And sometimes some machine learning algorithms have constraints, like they cannot work with features that are dependent of each other. It needs to have independent features. And so it depends on the type of machine learning algorithm that you're going to be using on your data. That's what I would say.
Looks like we have two more questions in the chat. Considering the rapid advancement of AI, what transformations and developments can we anticipate in the field of data science over the next 5 to 10 years?
So considering the advances in the natural language processing field, I feel that uh, there'll be a lot of advances that will help us to deal with unstructured data. So, like most of the data available out there in the web is unstructured. And with the emerging technologies in NLP, we can better deal with the natural language processing and unstructured data. And also, there's like another innovation because of the transformer models. We can develop like multimodal models which can like take an image input and give text output, or it can take text input and provide like an image output. So that's where most of the development would be, I assume. And people also have this like these days there's a lot of discussion around like development of an AGI, which is the artificial general intelligence, that will be like model that will have like a general understanding of our world. So I think most of the developments might be in that domain. Some might be around developing efficient methods to train models, and some might be around the architectures needed to train these AI models. I hope that answers your question. And there's another question. How is image pre-processing different from text pre-processing? So I feel there's a lot of similarity in image versus text pre-processing. It's just that the type of data is different. Like when we feed in an image, it will like every image will have some image related data, like its mapping in like there are those pixels, and every like image data will have something for every pixel, and then that pixel data can be transformed into features using these various transformer models like the recurrent neural networks and all of that. And the same applies for text data, it's text, but then all these deep learning models can be used to transform it into like an embedding representation. So even though they are different, but they also share like a lot of similarities. That's why deep learning can be used in both of these fields.
Great. It looks like we don't have any more questions in the chat. So a big thank you to our speaker for teaching everyone so much today. Do you have anything else you'd like to add before the end of our time?
Um, Nothing. Just thank you all for being here, and I just hope every one of you enjoyed the session and you keep continuing to learn and grow. That's it.
Thank you so much. Have a great rest of your day.
Thank you. Bye, everyone.